friction is the opposing force which opposes relative motion between two surfaces in contact. Okay, so what is this relative motion? When two surfaces are there in contact, think about it like this. So this is a floor or table or something. Okay, and this is a block over the table. Okay, and this is moving with a velocity v, and this is also moving with a velocity v. Okay, so what is happening? If both of them are moving with the same velocity, then when observer is here on this block, he will feel that this table is stationary relative to that person, right? So there won't be a frictional force acting between both of them, because for this observer or observing from this block, what he or she will be seeing as this table is always at the same position with respect to this block. So that's when we say that the relative motion or the relative velocity is zero there. So you won't see the friction is acting between both of them. Or if I'm saying the another thing is impending motion. What is impending motion? There is a tendency to move. Okay, so we will discuss about that in detail when we talk about types of friction. But in a just if I want to say, it is like, for example, I am trying to push a block. Okay, trying to push a block, but the resistance offered by the surface. Think about such a very rough surface, and I'm trying to push a block. So if it is very rough, intuitively you can imagine that the rough surface is going to provide a lot of friction. So you need to push that block with even more force so that there will be a motion happening. So if that maximum force that I'm providing is lesser than what is required, then the friction is trying due to the irregularity or the roughness of the surface, it won't move that smoothly, and that force which was supposed to provide that kind of velocity to that object uh, in reality could not um, could not induce that kind of motion. So that is what is called as impending motion. Another example of impending motion is, you can think about a huge wall. Okay, a huge wall is there, so you know that it is like concrete wall is there, and if you push that wall, it won't fall or move easily, right? So whenever I'm pushing, it is kind of like a I'm providing force, and you know that okay, if on an object, if you apply an external force, uh, that external force is supposed to move that object, right? And that supposed to move is called as impending motion. Okay, it is in reality it is not moving, but it has got a tendency to move. But because of this wall is like stuck to the floor with cement and everything, it is cemented, right? It has a strong resistive force which is given by the earth. I mean, this wall is stuck to some surface. So that's why this tendency to move remains as a tendency. It's not converted to a motion. So that is what is called impending motion. So friction is what? Friction opposes motion of an object. Okay. So friction is an opposing force which opposes relative motion or impending motion between two surfaces in contact. So it's a contact force. So contact force. So what is contact force and non-contact force? I've told you before also. So contact force is when you need to touch that object to uh, provide that force required, and non-contact forces when you do not need a physical contact between the object which we are applying the force and the observer or the other object which is like providing the force. For example, non-contact forces like magnetic force, right? Where if you are keeping the magnet nearby that object itself, that magnetic force will push or pull that object. But for example, if you want to push or pull using your muscular force, or if you want to tie that spring and push a block or pull a block, that's when you say that you are applying a contact. So friction is also contact force. So the causes of friction. So what causes this frictional force? So we can say that there is this intermolecular forces of attraction between molecules of the surfaces in contact. So what is this intermolecular forces of attraction? You have learned about cohesion and adhesion, right? Cohesion or cohesive force, and adhesive or adhesion or adhesive force. So what is the difference between cohesion and adhesion? Cohesion is when two molecules of the same material comes into contact. So like and like, they just get attracted very, or like molecules, like particles, or the molecules of the same material, they get attracted. That is called as cohesion. Okay. And adhesion is when two different materials are when they come into contact because of intermolecular forces of attraction, they stick together. That is called as adhesion. So you have another name of this commercial glue is called adhesives, right? Adhesive means what? Adhesives aid in sticking two different materials together, right? For example, if you want to stick a pipe to a wood material, or if you want to stick a mirror to a metal surface, you will be using a commercial glue and you will be sticking it, right? So that is what is called as adhesive. So similarly, here, if you are keeping if you keep any material together, you can see that if you are placing a book on a table, you can see that due to gravity, obviously this book is staying on the table. But other than that, also there will be relatively smaller, but again significant forces of attraction will be playing in between two molecules of book and the table. Okay, so that is called adhesive force. And cohesion or cohesive forces when two particles of the same material is there. For example, pages inside the pages of the book. So what is happening? It's the same material is there. So that force of attraction is cohesive force. So one second. So these are the forces that is what we are discussing here as intermolecular forces of attraction. Now, so that is at the molecular level, right? That's at the molecular level. Whenever I'm talking about adhesive and cohesive forces, it's this intermolecular forces of attraction that is happening. That is at the molecular level. At the macroscopic level, for example, if you use a lens or something, magnifying glass, you can see that any smooth surface is not that smooth. Okay, in reality, almost every smooth surfaces that you see in a real world, it's not really that smooth. Every surface will have a certain kind of irregularity over it. So when such irregularities are there on the surface, and I mean, we are talking about two surfaces coming into contact, right? For example, placing a book on a table. So book surface will also have, it's not that smooth. Okay, when you're using a magnifying glass, you will get to know. Even the surface of a paper, it's not that smooth. You will see that small, previously it used to be wheat, but now it's like you make the pulp out of it and you will be spreading it and you will be getting a paper, right? So that again, so the pulp, the cellulose is like it won't form a smooth surface. Will have certain kind of irregularities over the surface, and that irregularity plus the surface of the table, it will also have some kind of irregularity if you use the magnifying glasses, because wood is not that smooth. Okay, wood cannot form that smoother surface. If it was that smooth, what will happen? Lights will get reflected. You can see yourself as if you're seeing yourself in a mirror. So that is not happening. So again, mirror is the kind of a smooth surface. Again, everything is not 100% smooth. Okay. So friction. So this irregularity, it's like this. This is the surface of table. Okay. So there will be this small irregularities over the surface of the table. When you use a magnifying glass, you will get to see that the table. Okay, and you have a paper. I mean, a book over here, and this gap is like maybe like 10 micrometer. Okay, it's like very small gap that you're seeing. I'm enlarging the surface. Okay, then here also there will be small irregularities. So this irregularity will Okay, so this irregularity here will get stuck with this irregularity here. It will kind of like get stuck whenever you are moving. So this kind of resistance caused due to irregularities of the surface in a macroscopic level, or in a when you see using a magnifying glass, that will also contribute to the frictional force. Okay, so two causes are there. One is this intermolecular forces of attraction, and another one is irregularities of the surfaces in contact. Okay, now we will talk about types of friction. Two types of friction is there. One is static friction, another is kinetic friction. So what is static friction? When there is no relative motion, or if an object is at rest, it is when the static friction is happening. For example, uh, for example, you are keeping a block over here over a surface. Okay, and just like how I said, in real world all the surfaces will have some kind of irregularities and everything, due to which there will be a frictional force that is acting. Okay, so frictional force will act when, when you're placing it simply there, it won't the frictional force will not act, right? Why? Because friction comes into play when there is a impending motion or a relative motion. So what is this impending motion? Let me explain that now. So I am applying a small force in the sense like 0.001 Newton, very small force for a 1 kg block. Okay, this is a 1 kg block. So it's a very small force I am applying. So whatever is the magnitude of the force, if you apply a net force, it will it will tend to change the state of the object, right? If it is at rest, it will try to move it. If it is if it is moving, and if you are applying the force in the same direction of motion, then it will try to accelerate it. If you are trying to oppose the motion by applying force, then it will try to decelerate the motion. And if it is the force is large enough, then it will change the state of motion to state of rest for that object. So now this 0.001 Newton, even if it is a very small force, it is trying to create a motion for this object, right? So that is what is called as impending motion. So if this object is on a very smooth surface, what will happen? This 0.001 Newton will cause this mass into acceleration, right? Net force equal to mass times acceleration. So what will be the acceleration of this object? It will be 0.001 meter per second square, because it's 1 kg. Okay. So with this acceleration, this object will start moving. But since everything is not that smooth in real world, what will happen? There will be a frictional force that is acting. Okay. So frictional force will come into play as soon as the 0.001 Newton starts acting on this object. Okay, and it will try to oppose this force of 0.001 Newton. So that's why I have given the direction opposite to that of the applied external force. Okay, so this friction is going to oppose this 0.001, and you can see that usually the kind of um okay, the kind of normal reaction that will be here will be almost like 10 Newton. Okay, and uh, there will be something called as a coefficient of friction. Okay, so this is called mu is coefficient of friction is there, and you will calculate this frictional force as mu times n. Okay, so this frictional force equal to mu times n. Okay, so mu is something which is like between 0 to 1. Okay, mu equal to 0 to 1. So what will happen is uh, this coefficient of friction, even if it is like 0.01, what will happen? This F will be larger to counter this 0.001, right? So that is why this object will not move until a significantly larger external applied force is acted on it. Otherwise, it will be like if you breathe on a block itself, it will move, slide through the table, right? But it is not happening in reality. Why? Because the surface which we are keeping this block on will be providing this frictional force which will resist the motion. Okay. Now, static friction is when this relative motion is not there, only impending motion is there. So, what is the what will be the maximum frictional force that um, surface will provide? That is given by F max. Okay. Uh, so this F max is calculated using mu s times n. So what is this mu s? It's just the coefficient of static friction. Okay, coefficient of static friction. And there is another thing called coefficient of kinetic friction. Okay, coefficient of kinetic friction. Okay, now, uh, I have immediately given you another term, kinetic friction. So what is kinetic friction? Kinetic friction is when the object is sliding over a table. Again, you can imagine when I'm sliding an object over the table, frictional force will never vanish, right? You can think of it as the causes of friction are what? Intermolecular forces and the irregularities of the surface. It still stays there whenever we are moving an object over it, or if you're keeping it at rest. These two forces are always there, so there will be friction acting between these two surfaces. So when an object is moving, that is called as relative. When there is this relative motion is there between these two surfaces, then there is this kinetic friction that will come into play. And when it is kept, at rest, then it is called as static friction. So now, I'll come to this calculation of it. But before that, I wanted to discuss about something like how this frictional force acts as per the with respect to the applied force. Okay, so you will have something called like this. Okay, you have a setup like this where this is a surface, okay, which is obviously rough, not so smooth. Or so now we are talking about rough surfaces, okay, rough surface, and I'm saying that this surface can provide uh, a maximum friction of 20 Newton. Okay, 20 Newton can be provided. So how are we calculating this F max? F max is calculated using mu s n. So for every pair of surface, we have this coefficient of static friction and coefficient of kinetic friction. Everything is defined earlier. Okay. So for example, if I say that a paper and a wood, okay, between a paper and wood, mu s is constant and mu k is constant. Between a metal and the wood, mu s is constant, mu k is constant. Between a bed sheet and a plastic, then mu s is constant, mu k is constant. Okay, so these values are always fixed. What is changing? The normal force. So if I'm keeping a block, a metallic block of 10 kg over a wooden table, then the mu s will stay constant, mu k will stay constant, but this normal reaction will be what? It will be like, if it is a plain table, a horizontal table, and this is the metallic block here, 10 kg. So it will be like 100 Newton will be the normal reaction here, and mu s will be something of like 0.1. Okay, 0.1 is there. So that will compute to f of f max of what? 0.1 times 100 Newton, which will be 10 Newton. Okay, so that's how you calculate the f max. F max is the maximum static force that a surface can provide. Okay, so I was talking about maximum. So every time, is it required for the maximum one? For example, this is a block that we were talking about before. Okay, and I am applying a force here. So this is the applied force. Okay, and this is the frictional force. Okay, so I'm applying. First, I am applying the 0.5 Newton. Okay, let me draw a table over here. So it's like, okay, first I am applying. This is a table over here. So applied force and frictional force. Friction. Okay. So first I am applying 0.5 Newton. Okay. And you are observing that this block is at rest. Okay. This block is at rest. So what will be the frictional force? If say the maximum value of frictional force I have told you is 20 Newton. Okay. So if this 20 Newton is happening without any, applied force, say, when applied force is 0.5 Newton, and if F equal to 20 Newton, obviously there will be a motion to the left direction, right? So that is like, out of nowhere, this surface is providing this 20 Newton is absurd, right? So that is not happening. So this thing is like at rest, and you are applying this 0.5 Newton force. So this friction will also provide a 0.5 Newton to counter the motion. Okay, and then similarly, 1 Newton I am giving. So this friction will also provide this 1 Newton force to counter the motion. Then 5 Newton you are giving. Okay, 5 Newton friction will also contribute. Likewise, you can go up to what? 10 Newton, 10 Newton you will get. 15 Newton, 15 Newton you will get. Okay, once you give 20 Newton, 20 Newton you will be getting back. Okay, because F max is 20 Newton. What will happen when it is 20.0001 Newton? This can still give only 20 Newton. Because the surface can only provide maximum value of 20 Newton as the frictional force. It can oppose only, it's like you have a sister. Okay, so I am there, and my sister is here. Okay, she's like very young. Okay, she's like 5 years old, and I am 20 years old. So what will happen? I will push this person. She will also push me back. Okay, but you should understand that my sister is like very, she's not that strong compared to me. Okay, she's weak. So she can only provide some kind of like 15 Newton force. Okay. So she can uh, maximum of force that she can provide is 15 Newton force. For example, you have seen hand boxing, like hand punch, right? What is it called? Like, so you are holding like this. So there's this one person is here. Okay. And I am this another person. So we are trying to push each other. Okay. So it's like you are trying to push each other. So this person can provide only 50 Newton. This person can provide up to, like, I'm the stronger person here, so I can provide up to 100 Newton. So I'm slowly increasing from 1 Newton to 100 Newton. Okay, till 50 Newton, she will try to resist the push. So once I am, going beyond 50 Newton, 50.1 also, she will fail. Okay. So that is what is happening here. So 20 Newton, up to 20 Newton, friction can resist the motion. So if it goes beyond 20 Newton, even by 0.0001 Newton, then friction cannot resist it. So this block will start moving due to this 0.0001 Newton force. If it is like a 10 kg block, acceleration will be very feeble. Acceleration will be force by mass, which is equal to 0.000 and one more zero and one. Okay, meter per second square. So that will be the acceleration of this block. Now, another thing is, when this starts moving, see, even if this maximum force is 20 Newton, when the block starts moving, you have seen this thing, right? So when a car is there, car is moving, and there is this pitch is over here. Okay, when the car starts moving, see, for every speed, the way the car crosses the pitch will vary, right? For example, if a car is moving at a speed of 10 kilometer per hour, okay, 10 kilometer per hour, if the car is moving, then you feel that the car is hitting the pitch very hard. Okay, and once the speed is increasing, after a point of like 70 kilometer per hour or 80 kilometer per hour, you won't feel that the car has crossed the pitch. It will immediately, jump over this. I hope you understand that. It's like, due to the velocity, you will not feel that pit or irregularity as it is. Okay, there will be an impact, but it won't be that pronounced as uh, as when the object is moving slower. So similarly, when this block starts moving, the effect of the irregularity of the surface or the intermolecular forces, everything will start to fade down. So what will happen? This 20 Newton will become something like 19.999 Newton. Okay, a bit lower than the F max value. And this will continue even for 21 Newton also. It will be 19.999 Newton. For 19.99. For 22 also it will be 19.99. It will continue like that. Okay. So this is called as the kinetic friction. And this is called as the static friction. Okay. So static friction will vary according to the applied force, and kinetic friction will be a constant value, which is like, um, which will come into picture when once the object is moving, or if there is a relative motion between two surfaces. So what is this 20 Newton here? So what is this maximum value of this friction? It is called the limiting friction. Okay, that is what we are calculating using this F max value, which is F max equal to mu s times n. So the quotient of static friction times the normal force will give you the maximum value of the frictional force, which is called as the limiting friction. So now we will go back to um, drawing this graph. So this is a graph between frictional force and applied force. Okay. Uh, so so this is x-axis is applied force and y-axis is frictional force, and this is how it works. Okay. So first applied force I am giving 0.5. The frictional force will also be 0.5. Then applied force is 1 Newton, frictional is also 1 Newton. Applied force is 5 Newton, frictional is also 5 Newton. Applied force is 10 Newton, friction is also 10 Newton. Applied force is so it is going till 19 Newton. You will get frictional force. Then it will go up to here. Okay, applied force is 20 Newton, frictional force is also 20 Newton. Then it will drop down. When it becomes 21 Newton, it will be 19.9999. Then if it is 22 Newton, again 19.999. 23 Newton, and it goes like that. Okay. So that will become a parallel line to an x-axis. Okay. So when I'm joining it, it will look something like, okay. So this higher peak value is called limiting friction. Okay. And this parallel value or the constant value is called kinetic friction. Okay. And so now for uh, solving the problem, to know about how to calculate FA, that is the kinetic friction, and static friction, how it works, that also you should know. Okay. So static friction is something which is like, okay, so whatever I am applying, only that much will be uh, given back by the static friction, right? So that's why that is kind of like a y equal to x thing. Okay, where x is applied force and y is frictional force, right? So frictional force. So y equal to x line will give you a slope of 45 degrees. So always whenever you are drawing a graph between uh, frictional force and applied force, the slope of that straight line, initial straight line, will be 45 degrees, and later it will reach a limiting force, a limiting frictional force, and then from there it will, it will have a slight decrease from the limiting force and changes into kinetic friction, and that kinetic friction will stay constant up and until whatever force you are applying, this kinetic force friction will be the constant opposing force or the constant resistive force that will always be in the picture. Okay, so you should understand that this F max is always, or I mean always greater than or equal to Fk. Okay, so F max is either greater than the kinetic friction or it is equal to kinetic friction, but Fk, I mean, okay, so this is another relation that we will be having here. So F max is always greater than or equal to Fk, and Fs is always proportional to applied force when applied forces less than or equal to F F max. Okay, F max. Now, so the static friction, we were saying what? Law of static friction is what? Uh, Law of static friction is limiting friction is always proportional to the normal reaction which is provided to the conducting surface. Okay, so F max that is the limiting friction, is proportional to n. So that proportionality is taken over by F max equal to mu s n, and this mu s is coefficient of static friction. Okay. Now, similarly, law of kinetic friction is there. Which is equal to kinetic friction is again uh, proportional to normal reaction between the surface of contact, two surface of contact. So sorry, Fk is proportional to n, and Fk, the proportionality changing into equality will give you a constant of proportion mu k times n, where mu k is the coefficient of kinetic friction. Okay. So F max is always greater than or equal to Fk that we have seen. That means mu s is mu s n is always greater than or equal to mu k n. So n and n will always be same. So mu s is always greater than or equal to mu k. This is a very important result. Okay. So if I'm saying that a surface is having a surface um, is having two mu, okay, two mu values. One is mu equal to zero 0.3 and mu equal to 0.2. Which one is kinetic and which one is static? Static one will be the larger one. That is, so mu equal to 0.3 will be mu s, and mu equal to 0.2 is mu k. Okay. So that is how you take it. So I'm for problem solving, I'm saying that there's this surface is there, and the block is placed over a surface, and I'm saying there are two values are there, mu equal to 0.3 and mu equal to 0.2, and I'm saying calculate uh, calculate the acceleration of the block when F equal to, okay, this block is like 10 Newton, so uh, F equal to 5 Newton and F equal to 100 Newton. I want to calculate. So what will I do? So for the first one, F equal to 5 Newton, I'll see the normal reaction is 100. Sorry, this 10 kg block. Okay, 10 kg block will give you 100. Sorry, so this is 100 Newton is there. So 100 Newton times. Uh, so first I'll calculate F max. Okay, F max is what? 100 times. You will get to know that a larger one will always be mu s and the smaller one is always mu k. So I'll take mu s value as 0.3, and that is 30 Newton. Okay. So 5 Newton, what will happen? If I apply 5 Newton, F max can go up to 30 Newton. So it will also, this frictional force here will be what? Just 5 Newton. Because whatever I am applying up and until it exceeds F max or reaches F max, it will always provide what is equal to the applied force. So F here will be what? 5 Newton. Okay, and acceleration of the block will be equal to 0. So for the second case, what will happen? 100 Newton is here. So 100 Newton I am applying. And so the maximum frictional force is 30 Newton. But you know that now that block will move because it's 30 Newton is already there. So block will move means I have, so that is Fk equal to 100 times mu k, that is equal to 20 Newton. So here it will oppose with 20 Newton. So the net force equal to 100 minus 20 Newton, that is 80 Newton, and acceleration equal to 80 by 10, that is 8 meter per second square. Very anyway. So that's how you calculate friction when it comes to example problem. Okay. Another example problem that we will see right now is like, so there's this block of 5 kg. There's this block of 5 kg over a rough surface with mu equal to 0.5. Okay. And there's this block of 5 kg that I've told before. And now we are applying a force of 5 Newton over here. Okay. Now what I'm supposed to do is find acceleration of the block and find the frictional force. Find acceleration of the block and find the frictional force between block and the surface. Frictional force. Okay. So first I'll do what? I'll draw a free body diagram of the block. The FBD of the block will be like 5 kg is here. So 50 Newton will act downwards. Because of that, there will be normal reaction. And since the block is not moving in vertical direction, N equal to 50 Newton. Now there's a applied force towards this side. That is 5 Newton. And because of this 5 Newton, what will happen? 5 Newton is acting that side. So frictional force will act in the opposite direction. That is F towards the left direction. So this F we want to find first. How much is the limiting friction that we need to find? So what is the limiting friction over here? The limiting friction is F max equal to mu Sn. So what is mu s? Mu s or mu, only one value is given. So we'll be taking that value. That is 0.5 times 50 equal to 25. Okay. So 25 Newton is here. So we know that whatever we are applying, the same proportional frictional force will be given back by the surface, and up and until it is the applied force is equal to F max value. So here 25 Newton is the F max value, and whatever we are applying is very less than F max value. So F will be what? 5 Newton. So we found the frictional force, right? Frictional force we found. Now acceleration, what will happen? So applied force is countered by frictional force. Applied force is countered by frictional force. So what will happen? The block won't move. Block is at rest. So acceleration equal to 0 meter per second square. That's it. So there is no horizontal motion, there is no vertical motion. So that is the this is the key concept of friction. So you should understand how to calculate a limiting frictional force, and then you should know how to calculate the acceleration using that frictional force. Okay, so limiting friction or the maximum frictional force is the key concept here. Based on that only, you will have two different situations. One is like applied force is less than the limiting friction, where the frictional force will whatever frictional force is there between the surface will be proportional to what we are applying, and the object will be at rest. And there will be this another case where applied force is larger than the frictional force. Then another friction will come into contact, which is this Fk, kinetic friction. So that value you have to calculate using mu k, that is the coefficient of kinetic friction. And with that, you will calculate the opposing or the resistive force, frictional force that is in the problem. And a net force you will calculate. And from the net force, you will be getting the acceleration. Okay. Now, in this case, what if this object was having is having an external force of 30 Newton? Let's see that. So this is the surface. This is a block which is like 5 kg here, and 30 Newton force is acting on it, and mu is again constant 5.5 is there. Now you need to calculate the acceleration and the frictional force. Calculate acceleration of the block and frictional force. Okay. So what will you do? Again, we have calculated F max over here. So first of all, free body diagram we have to draw. So this is 50 Newton acting downwards and N acting upwards, and 30 Newton acting towards the right. So N equal to 50 Newton because there is no vertical motion. So F max is 0.5 times 50 Newton, which is equal to 25 Newton. Applied force is larger than F max. Greater than F max. So there will be a motion. So what is that motion? Again, mu k, only one mu is given. So we will take it as mu k and mu s. Okay. Sometimes that can also happen. So here Fk will be calculated again using what? Mu k times n. So mu k here again it's 0.5 times n is 50, which is equal to 25 Newton. So this mu Fk will oppose the motion of this block. So net force equal to 30 minus Fk, which is equal to 5 Newton. So net force equal to mass times acceleration. Net force is 5 Newton. Mass is 5 kg. And acceleration is what we want to find. That is 1 meter per second square. So you have found the frictional force and you have found the acceleration. Now, another problem we will see is okay. So you need to calculate friction and acceleration of the block. Okay. The block setup is something like this. So this is a rough surface. Rough surface. Mu equal to 0.5 and 0.4 is given. It's a 5 kg block and 30 Newton is applied. Okay. Now what are we supposed to do? First we will draw free body diagram of this block. So this is 50 Newton down. That's the weight of the block. Then normal reaction will be there. And 30 Newton is here. And what will happen? First we will be calculating F max. F max equal to mu s times n. So what is mu s? We know mu s is greater than mu k. Mu s is always greater than or equal to mu k. When two values are given, the larger value will be mu s. So what is the mu s value here? 0.5 times equal to 25 Newton. Okay. Now, applied force is 30 Newton and the other one is 25 Newton. So applied force is larger than F. So what will come into play? Kinetic. So what is kinetic friction over here? So here kinetic friction will oppose the applied. So what is kinetic friction here? Fk equal to mu k times n. What is mu k here? 0.4. Why? These two values are given. The smaller one will be mu k and the larger one will be mu s. So 0.4 times n, that is equal to 0.4 times 50, right? So 20 Newton. Okay. Now 20 Newton is opposing 30 Newton. So net force is 30 minus 20 equal to 10 Newton. And 10 Newton equal to mass times acceleration, that is 5 times A equal to 2 meter per second square. That is how you calculate the acceleration and frictional force when you are given with mu k and mu s value. Okay. Now we will just do one more problem, which is to understand the components of forces. Okay. So again, question is calculate acceleration of the block and friction. Setup is like this. So this is the surface. Okay. Mu equal to 0.5. And there's a block over here, which is of 5 kg. It is being pulled by a force of 30 Newton at an angle of 37 degrees. Okay. Now you need to find the friction and acceleration of the block. So first what we will do, we will draw a free body diagram. Solution is, so this is the free body diagram of the block. So this is having a 50 Newton weight. Normal reaction is here. And this 30 Newton, it will have two components. 30 Newton is here. So it can be resolved into two components. One is this horizontal component and another one is this vertical component. So this 37 degree will contribute to 30 cos 37 degree and this will be 30 sine 37. Right. So now you can see the normal reaction plus 30 sine 37 degree is countering 50 Newton because there is no vertical motion. So n equal to what? So the sine 37 is 3 by 4. Okay. 3 by 5. Okay. So this value is 30 times 3 by 5 is equal to 18. And this value is 30 times 4 by 5, which is equal to 24 Newton. Okay. So n plus 18 equal to 50 Newton. So n equal to 32. So you found the normal reaction. Now what will you do? You want to calculate the friction and acceleration of the block, right? So we will calculate limiting friction first. What is the limiting friction over here? Mu n. So what is mu? 0.5. What is n? 32. So that is equal to, right, 16 Newton. So 16 Newton is here. And what is the horizontal force over here? That is 24 Newton, right? So 24 Newton. So again, I will draw the block over here. So here N is there, N plus 18, and here is 15 Newton is here, and here 24 Newton is there, and there is this frictional force opposing. Okay, so what is this frictional force? Static or kinetic? So this 24 Newton is obviously larger than 16 Newton. So F is larger than F max. So this will be Fk. Again, Fk or Fs. Here only one mu is given. So what we will do is calculate Fk using mu n. Again, mu is 0.5, n is 32, which is equal to 16 Newton. So here Fk is F equal to F max. So 16 Newton will be here. So 24 minus 16 is the net force, which is equal to mass times acceleration. 8 equal to 5a. A equal to 8 by 5 equal to 1.6 meter per second square. That is the force of it. I was saying that why we are taking normal reaction and not the weight of the object directly. Because every time it's not the weight of the object that is contributing the frictional force. It's the normal reaction that creates the change in the frictional force. So if there is a assistance of a external force to counter the weight, then the force which is being exerted on the surface which comes into contact of the block, that will experience a lesser force than the weight of the object. That's why we are specifying you have to always consider the normal reaction. Similarly, if we are pulling this block, what will happen? This block is being pulled, uh, uh, yeah, pushed by F equal to 30 Newton at an angle of 37 degrees. Okay, rest everything remains constant. Mu equal to 0.5. What will happen for the acceleration of block? Again, you have to resolve this block. So this is the FBD of the block. So this will have 50 Newton. This is 5 kg. Okay, again. So 50 Newton. Then there will be N will be there. And this block is being pushed, right? So pushing means 30 Newton here. You will resolve it into two components. One is the horizontal component. So this is the 37-degree angle. The horizontal component is what? That is 30 cos 37 degrees, which is equal to 24 Newton. Okay. And you will have a vertical component, which is 30 sine 37 degrees, which is equal to 16 Newton. Okay. Now you have to write this as N equal to 50 plus 16 Newton. Now normal reaction has increased. That is 66 Newton. Right. Equating the vertical forces. 66 Newton. Now F max equal to what? Mu times N has become obviously larger one, right? 33 Newton you're getting as frictional force. Okay. Now applied force is less than F max. So what will be the frictional force here? Frictional force will be equal to applied force, which is equal to 24 Newton. So the frictional force here will be 24 Newton, and the object will be at rest. Right. Sorry, this is not 16, it's 80. Okay. A small mistake. 68. So it will be 34 Newton. But again, it doesn't matter. The theory remains the same. Just like, so 34 Newton is the maximum limiting friction. and applied force is less than the limiting friction. So whatever we have applied, only that we will be getting as the frictional force, that is equal to 24 Newton. So the object will be at rest. So acceleration equal to 0. I hope you understood the concepts that was discussed today. Thank you and have a great day.